In the last episode, the Next Gen Stats team gave us a high-level overview of how they take player tracking data and turn it into advanced statistics. But now it's time to go deeper. To start with, how do they actually ingest and store the billions of data points that are created each season? Well, let's find out. There's a massive amount of data coming from the stadium and being ingested into AWS for this solution. So can you walk me through what that process looks like?
The servers in the stadium are collecting and smoothing all of that data from the RF chips and streaming it directly to our servers in AWS. We built a special streaming server written in Java to receive all of that data, and then that gets put into our processing pipeline, which includes Java processes, Node processes, even Python processes to build stats based off of the tracking data.
So when you're ingesting all of this data, it needs to be in real time. What types of technologies exist to support that real-time streaming use case?
Right, so our streaming server will receive the raw tracking data and push all of that data into Kafka, which we use for our messaging broker.
Apache Kafka is a high-speed distributed streaming platform built to handle millions of messages per second of real-time data. AWS offers a service called Amazon Managed Streaming for Apache Kafka, or MSK, which handles the operations, maintenance, and scaling of Kafka clusters so that you can easily run Kafka clusters on AWS. Think of it like a central messaging hub that connects systems. Instead of one app sending data directly to another, Kafka organizes data into topics, like channels, where producers write streams of data and consumers read from those streams. In the context of NFL Next Gen Stats, all that RFID data flows into Kafka. Kafka captures the streams and makes them available to multiple processors at once.
All of our processors are consumers off of one of hundreds of different Kafka topics. Once a particular processor is done doing its work, it throws a message into Kafka so that the next processor can pick it up and begin working its step of the pipeline.
So you're using Kafka as like a message broker to distribute these events to the different processors at different points in the pipeline?
That's correct. We have some topics where we've got 20 consumers, and we've got some topics where there's only one consumer. But we've architected the backend so that all of this can be done in parallel so that we're able to build these stats as quickly as possible.
Once the data has been distributed to the processors, there's going to be some sort of storage mechanism that has to happen. So where are you storing things like the raw tracking data, for example?
We store the raw tracking data in a few different locations. Our project started with Mongo, and all of our raw tracking data got stored into Mongo, and then we used S3 as a backup for our raw tracking data. And then as time went on, we saw that the data just kept on growing. There's over 2 gigabytes of raw tracking data per game. That's a lot of data to be able to query against. We tried a few different technologies, but we eventually arrived at Cassandra, which allowed us to have a very consistent query response time, regardless of how much data exists in the database.
Different parts of NFL Next Gen Stats need different database solutions, and AWS offers multiple purpose-built databases because each type of database excels at specific use cases. Relational databases, like PostgreSQL or MySQL, provide structured storage with defined schemas, and they handle complex queries across multiple tables. Amazon Relational Database Service, or RDS, allows you to easily create relational databases and manages the underlying infrastructure. Non-relational databases like Cassandra or MongoDB offer highly scalable and flexible storage. Amazon DocumentDB provides MongoDB-compatible document storage, and Amazon KeySpaces provides a Cassandra-compatible database with zero infrastructure management. These NoSQL databases shine when you need flexibility and speed at scale. It's all about using the right tool for the job. Why NoSQL for the raw data?
In the beginning, we weren't sure what we had. By working with NoSQL databases, we were untethered to a very strict data structure, And that enabled us to proof of concept quickly. We could try different stats, we could try different ways of querying against the data, and it wouldn't require a lot of operational overhead to redo or undo some of those changes.
So that's for the raw data, but for the process data, like once the stat is actually created and the processors have done their job, where are you storing that type of data?
Mongo is still our live database for all of our derived stats. We also use Postgres as a relational database to power our QuickSight BI tool. Now, the QuickSight BI tool has really enabled our researchers to query against the data in new and interesting ways. They want to see how a quarterback performs when there's 8 or more in the box or against the blitz. And QuickSight has enabled them to find this data quickly.
So it really sounds like you are choosing the right tool for the job, right? So you're not just using one database or one storage solution for every use case.
That's correct. We firmly believe that there's the right tool for the job, and we want to make sure that we're providing our analysts the best and fastest way to access the data. And there are different database solutions that can accomplish these things.
In the next episode, we'll find out how the team actually turns that raw tracking data into advanced stats using machine learning and Amazon SageMaker.